Welcome to our workshop on Algebra Lesson 1-7. Today we're going to be talking about the distributive property. All right, so we're almost near the end of our topic 1. We've gone through 1 through 1-7 today. 1-8, or I believe 1-9. Let me double check for you so you know. Our last one in this chapter is going to be 1-9, and then we'll have our first algebra test. So just so you are aware of the pacing here, we're going to go ahead and get started with our anticipatory set. All right. So one of my friends in college, we were both very big fans of video games. We still are, and we love co-op video games. If you've never played a co-op video game before, it's basically you and someone else are playing. You're not playing by yourself. So both of us, what we would do is we would, every once in a while, meet up and have our video game time. So let's let you see sort of what it looked like here. We got some, this is my friend. He has a controller in his hand right now, we'll say, and he's very excited. He's smiling. This was me over here standing up because I'm so excited that he found the thing he did. There's my controller. Oh, that's a bad controller. But anyway, there's my hair, and I was very excited. So both of us are playing this video game, and I remember it well. The video game we were playing was based on The Lord of the Rings. So we'll pretend my TV was that. You know what? Yeah, that's fine. It's big enough like that. So we're playing video games, and this is the TV right here. And as we were playing, the game we were playing was called The War in the North. Now, I guess it could be about the Civil War, which we'll be learning about, but no. This was about Lord of the Rings. This was a game where we played as characters from Lord of the Rings. So let me give you a little peek inside of our video game. So in this game with Lord of the Rings, you're part of a team. So inside the TV, you were part of a team. Now, my friend Kevin, this guy right here, he liked to be the dwarf. And the dwarves in Lord of the Rings, they're sort of stocky, they're big. There we go. They got thick legs, thick arms. They like to battle with axes. So here's his big old head. He had a helmet on that sort of went in between his eyes to protect him. He's not supposed to be super happy, but there we go. His weapon that he would always use was this big sort of axe that was very dangerous looking. There we go. That was his weapon, and he had a big old shaggy beard and hair, and that was what my friend liked to play as. He was the dwarf. Now for me, there was the other character. There were two other characters left, and I went ahead and I was the human. So I guess I was the boring character, but it was a human guy, and it was much more sort of stealth. I wasn't big and strong, but I would always wear like a hood to protect, I don't know, or just maybe to look cool. And I would always have a cape, and in my hand I always used a bow, and in my other hand I would always carry maybe some arrows. There we go. It's not bad drawings. So in this game, everyone had their own sort of skills. So from what we would do, the reason we were so good when we were playing together, maybe good, I don't know. But he was more the strength guy. He would go in, he would help out in situations, and I would be more finesse, and I would stay away, and I would shoot my arrows into the problem areas, and that's sort of what we did. And the way you played this game was when you got to the end of each level, it sort of gave us each a readout of like, I have this much strength, and I have this much power, and so it would give you sort of if you ever played a game like that, it's sort of you had to earn things, you had to find things and pick them up, and when you were wearing this different hood, it would give you different powers, and when you found a necklace, it would give you different powers. And then one day, the reason I'm so excited here, and the reason he was all excited, was he found something on the ground. Now, if you know Lord of the Rings, one of the main things about Lord of the Rings is the ring, but this was not that ring, but it was a different one. And he found a ring laying on the ground. He went to pick it up, and he saw that when he picked it up, it was going to power him up plus 18, which is unheard of. It was the most amazing thing you could find. And then, so we were all excited, but I was a little bit of but the thing was, this ring applied to our entire party. So his power up also powered me up. And we played the next couple levels so easily because we were both super powered up, and it was pretty impressive. Now, if you ever get the chance, I would play that game. It was a lot of fun. But anyway, let's go ahead and get into some math. I gotta say, that's pretty good art for Mr. Barrett today. All right, here we go. Let's get into some math. What we're going to be talking about today is a standard we've used before, which is standard A for algebra, A.SSE.A.1a. So we've used this one before. I believe this is the one we used way back in our first lesson as well. And this standard, we're just going to write a portion of the standard down right now. And it says to interpret parts of an expression such as terms and not too bad of a standard to write down today. So that's what we're using. We're interpreting parts of expressions. We're understanding what these expressions are doing, and items such as terms, factors, and coefficients. So let's go ahead and get right on into our input. And we're going to start off input with a few language of the discipline. Some of this you may know, but it's always good to have these terms down and know when we're going to need them. So the first term is going to be something we've heard about for a very, very long time, but it is the distributive property. The distributive property, which, look at that, it's the name of our lesson today. The distributive property. And the distributive property it is a property, surprise, surprise, it's a property of real numbers that helps simplify expressions. A property of real numbers that helps simplify expressions. And now the book actually gives us a really good image of this. So I wanted to write down this image that you see in the book there. And the way it writes it down is it gives a box, a nice visual, spatial way of seeing this. And then in the box, it says, or it shows that one side is 8 and the other side is x plus 5. And it shows that we know how to do that. If we knew what x was, we could go ahead and find the area of this, or we could figure out anything like that. But then it shows a box next to it, the exact same size. And then again, it has 8. But then it doesn't have x plus 5 on the bottom. Actually, the box is split into 2 parts. And on one side, it says x. And the other side, it says 5. And it shows that the same thing right here, 8 times x plus 5 is the same thing as saying 8 times x plus 8 times 5. So it says that 8 times x plus 5 is the same thing as saying 8 times x plus 8 times 5. It's the same thing. So that was, I thought, a nice way of showing what the distributive property was. Okay, now based on the the terms that we hear in our standard, we're going to write a few other ones down. The first one is actually term. Term. And what a term is, it is a number, variable, or the product of a number, and one or more variables. Now, if you think about that, that covers a lot. That covers a number, any variable, or the product of any number and any variable or variables. So it's pretty much everything. Everything can be a term, and we'll see that as we go into some of the stuff we're learning about today. The next one is going to be constant. What is a constant? A constant is a term that has no variable. A term that has no variable. It is constant. 5 will always be 5. A million will always be a million. All right, the next one is a coefficient. And a coefficient is just a numerical factor of a term. Remember, a term can be a number, a variable, or the product of a number and one or more variables. So a coefficient, and I'll go ahead and put an example of what a coefficient can be. If we have the term 4x, the coefficient is this part right there, just the numerical factor of a term. The x is the variable, the 4 is the coefficient. And finally, our last one is going to be like terms. Like terms. And like terms are terms, oh, surprise, surprise, like terms are terms, with the same variable factor. Variable factor. So if we're looking down here, if I have a number 2 or a term 2a and I have a term 3a, they are like terms. And the great thing about like terms is you can then combine them. If it was 2a plus 3a, you'd be able to say, oh yes, that's 5a. Like terms are combined. Oh, I'm so sorry. You couldn't see anything I was just writing. That was horrible of me. So 2a and 3a are like terms. 2a plus 3a is then going to be 5a because they are combinable. Combinable. I like that word. All right. Let's go ahead and move on to our details. Now I'm running out of room here, so I'm going to go ahead and switch out the paper. And let's get some details. There we go. Okay. So let's go ahead and draw a flower for our details. Oh, it's a bad flower. That's okay. The first thing we're going to talk about is how to simplify using the distributive property. Okay, simplify using the distributive property. Now, I'm sure we all have all done this at a certain time in our life, but let's go ahead and get it here. So let's do a simple one first. What is the simplified form of 3 times x plus 8? And the way we say that is, what is the simplified form of 3 times the quantity x plus 8? So anything in the parentheses you can call the quantity. 3 times the quantity of x plus 8. Okay? So now let's go ahead, and I'm going to go ahead and put some steps down. So step 1. And in step 1, the way we always should use our steps, please write it out. Write it out. Always, you know what? Exclamation mark. Write it out. Always write it out. So, what is the simplified version or simplified form of 3 times the quantity x plus 8? Well, let's go ahead and rewrite 3 times the quantity x plus 8. That's step 1. Always should be your step 1. Step 2 is to use the distributive property. Okay, and when we use the distributive property, just like in my video game, when my friend Kevin picked up this powerful ring that gave us each plus 18, it does not only go to 1, it goes to both. It distributes out. So when we go to our distributive property, we take this 3, let me use a different color. Got the colors, I might as well use them. And the 3 will distribute to the x, and the 3 will distribute to the 8, leaving us with a new equation that equals the same thing, and that will be 3 times x plus 3 times 8. The 3 distributes out and is now multiplied to both. All right, and then finally, we go to our step 3. And in step 3, we simplify. As always, we'll simplify. So I'll just drop down here as I'm simplifying. 3 times x will be 3x plus 3 times 8 is 24. There's nothing more I can do with this because these are not like terms. This is a constant, does not have a variable. This has a variable of x with a power of 1. There's nothing else I can do. That's my answer. So that's a pretty simple one. You've probably even done that before in previous grades. You should have, because it's standards in other grades too. But now, what if it looks different? That's the most basic way of solving our distributive property. What if it looks different? What happens if it looks different? What happens if it looks like, let's say, 5, or the quantity 5b minus 4 times negative 7. This looks significantly different from this, right? And if it doesn't look the same, the rule is to follow the known rules. You know how numbers react with one another. Just make sure you're following those reactions the same way. So let's go ahead and go to step 1. And in step 1, we're going to write it out. It's going to be these same steps, okay? So I'm going to go ahead and write it out. 5b minus 4 times negative 7. So I wrote it out. Step 2. Look up there. Use the distributive property, right? And it doesn't matter that the term we're going to be distributing is over here now. Imagine if while we're walking through, I was the one that found this ring and picked it up. It would still distribute to both of us. Doesn't matter where it is. So we're going to distribute the -7 to the -4 and the -7 to the 5b. Doesn't matter. It's in the same place. And this will then equal 5. Oh, I'm using the wrong color. 5b times -7 plus 4. Oh, sorry. -4 times -7. And then step 3 of any math problem is to simplify. And this will then simplify 5b times -7. Well, we can multiply those numbers. That's going to be -35b plus -4 times -7. Since those are the same sign, they're going to be positive, plus 28. I can't do anything else because they are not like terms. And that is the end right there. Okay, so we have that figured out. Now, what if there is a fraction? What if there's a fraction? So we've done it a simple way. We've done it if it looks a little different. Now, what if there's a fraction? Now, remember, when you are working with fractions, fractions indicate division. Right? Fractions are just a way of showing division. So if we have a problem, and the problem is 7x plus 2 over 5. We're looking at that. Well, that 5 over 5, that just means division. So this is going to equal 7x plus 2 divided by 5. It's the same thing. That's all a fraction is showing. And we can remember that when it comes to something like this, you can multiply by the inverse. You can multiply by the inverse. Well, the inverse of 5 is going to be 1/5. So it's actually going to be, we have 7x plus 2 over 5, and that now becomes 7x plus 2 multiplied by 1 over 5, which is the same thing because those are inverse. So we can go ahead and do that. Now use the distributive property. Now that we have it figured out like that, now it looks like we can use the distributive property. So what we have right now is 7x plus 2 times 1 over 5. So what we need to do is the same thing we've been doing before. The 1 over 5 is going to distribute to the 2, and the 1 over 5 is going to distribute to the 7x. And this is now going to equal 7x times 1 over 5 plus 2 times 1 over 5. And from there, we can go ahead and simplify it. So 7 times 1 over 5 is going to be 7 over 5. Can't forget our x, plus 2 times 1 over 5 is going to be 2 over 5. We cannot simplify this any further because these are not like terms, and there we go. So now we've covered the simple way, we've covered if it looks different, now we've covered if there are fractions. Let's go into something else. I'm running out of space here, so I'm going to go ahead and switch to a different piece of paper. There we go. And the next thing we're going to go into is using a property. And the property we're going to use is the multiplication property of -1. Okay, so if we're using the multiplication property of -1, one thing we need to remember, I'll put it with a little star over on this side, is that if you have something like -x, that can always be split out to -1 times x. Negative can just be used with multiplication of -1, because anything times -1 is going to be its inverse, right? Its opposite is going to be anytime we do that. So if we see that we have a problem like -2y, or negative the quantity 2y minus 3x, and we see that negative out in front, there's definitely something we can do with that. And all we need to worry about is this. It's the same thing. So this negative can become -1 times the quantity of 2y minus 3x. So all we had to do, that negative becomes a -1. Now we use our distributive property. The -1 applies to the 2y, and the -1 applies to the 3x, which then gives us -1 times 2y plus -1 times -3x. And we just need to simplify that. -1 times 2y, it's just going to be its inverse, which is going to be -2y plus -1 times -3x. Those are both the same sign, which means that's going to be positive. It's going to be, its inverse, 3x. So -2y plus 3x, there's nothing else we can do because those are not like terms. And there we go. And now finally, let's get into what I have been constantly saying this whole time, which is using like terms. Using like terms. Terms with the same variable, and exponents can be combined. All right. So let's go ahead and look at a basic one, and then we'll do some modeling. We have 8x squared plus 2x squared. We have the same variable, x, and the same exponent, 2. So these can be combined. Now, to make a short story long, we could just go ahead and say we can use the distributive property of this by going 8 minus 2x squared, and then we can fill it in right there. Oops, sorry. I've been doing this wrong the whole time. Plus 2 gives us 10x squared, or you can just realize that those are like terms and you can go ahead and add them. And that's all I need to really say about using the like term. So let's go into some modeling. I only have 2 modeling questions because we've done so many questions in our actual lesson. But the first one, I want to do a complex one of these using like terms, where there's more than one type of term to use. So let's go ahead and say -3x squared minus 2y plus 4x squared minus 3 plus 8y. All right, it's a long string of terms, right? But we know which ones can be organized or which ones can be combined. So the first thing to do, so we have a little bit more control over all this, is to rewrite this as a sum. Rewrite everything with addition, so it's easier for us to change some things around. So that'll be negative 3x squared. Now instead of subtracting, I'm going to add and just say negative 2y. So plus negative 2y plus 4x squared, we're fine there. But here again, there's a negative, so I have to go plus negative 3. And then we're fine at the back, 8y. Now that it's all addition, we can do something wonderful called commutative property. The commutative property. And in the commutative property, we can now adjust these terms into the order that we like best, meaning let's get all our like terms together. So negative 3x squared, where's the next x squared? Oh, it's right there. So I'm going to take this and move it closer. Plus 4x squared. Now what's next? Plus negative 2y. And is there any other term with negative or with y? Yes, at the very end. So we're going to take this and move it up too. Plus 8y. And then let's put the last bit on the end, negative 3. And then we just go to our old friend simplify. And now each of these terms that are next to each other can be combined. Negative 3x squared plus 4x squared. Well, negative 3 plus 4 will give us 1. We don't have to write the 1, so it's just going to be x squared plus negative 2y plus 8y. Well, negative 2 plus 8 is going to give us positive 6y. And negative 3 can't be combined with anything, so it's going to be minus 3. None of those terms are like, so we can't put them together. So that is our answer right there. All right, let's get one more done. And this one's just a simple one as well. Number 2, let's see if we can go back and remember this. Negative 3x minus 7 equals. That's it. And once again, just real quick, we're going to go ahead and change this negative to negative 1 and the quantity of 3x minus 7. And then we go ahead and we distribute the negative 1 to the 3x and the negative 1 to the negative 7. And we're going to end up with negative 1 times 3x plus negative 1 times negative 7. This is going to make this the opposite, so it's going to be negative 3x plus, it's going to make the opposite, which is 7. Negative 3x plus 7. So once you get the hang of it, these questions go pretty quick. So now comes the important part, where I'm going to explain how we're going to be doing our independent practice differently, because I found something super cool. So looking over here, I'm going to go ahead and say guided practice. And your guided practice, as before, is going to be PPSE, which is those practice questions that are there. And you're going to do number 13 through 39 odd. And then you're going to pick it up again on number 51 through 63 odd. And then for our independent practice, I've actually assigned it on your Pearson SuccessNet web portal. If you go there, you'll see a button next to Explore that says To Do. And I went ahead and assigned all of the homework from this week because I found it and I was all excited about it. You only need to do the one from tonight, but if you want to, you can go do the other ones as well, especially since we have our test coming up next week. And you're going to do lesson quiz for lesson 1-7. Now this is more online. You'll get immediate feedback from it. You'll be able to click your answers in and then submit it, and it'll tell you which ones you got right and which ones you got wrong. So very excited about that. So go ahead and do that one. You do not need to do the self-assessment anymore. You can just go ahead and do the lesson quiz 1-7. That's it for me. Have a wonderful day, and as always, go Buffs.